The universe is vast. It's filled with billions upon billions of stars, each one a potential host to its own family of planets. And around those stars, planets dance in a cosmic ballet, each with its own unique characteristics and mysteries. In 2016, astronomers made a discovery that sent ripples of excitement through the scientific community. They found a star system just 40 light-years away, with not one, not two, but 7 Earth-sized planets. This system, named TRAPPIST-1, instantly became a beacon of hope in our search for life beyond Earth. Why? Because 3 of these planets orbit their star within the habitable zone. This is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. And as we know, water is essential for life as we understand it. The discovery of TRAPPIST-1 was groundbreaking. It showed us that planetary systems like ours with potentially habitable worlds could be more common than we ever imagined. Suddenly, the dream of finding life beyond Earth felt a little closer, a little more real. This discovery opened up a Pandora's box of questions. Could these planets really harbor life? Could they have the right conditions for life to thrive? What would that life be like? Would it be similar to life on Earth or something entirely different? And could we ever travel to this distant star system and see for ourselves? The possibilities are endless, and the journey has just begun. The star at the heart of the TRAPPIST-1 system is a far cry from our own sun. It's an ultra-cool red dwarf star, significantly smaller and cooler than our sun. Imagine a star so dim that it barely flickers in the vastness of space. That's TRAPPIST-1, but don't let its size fool you. This tiny star is a cosmic choreographer commanding the movements of its 7 planetary dancers. These planets are all roughly the size of Earth. Rocky worlds with the potential for solid surfaces. They're locked in a tight orbital dance much closer to their star than Earth is to the sun. Imagine a celestial waltz, with the planets gracefully gliding around their stellar partner. This proximity means that the planets experience frequent transits, passing in front of their star from our perspective. These transits are what allowed astronomers to discover the TRAPPIST-1 system in the first place. Of the 7 planets in the TRAPPIST-1 system, 3 stand out: planets E, F, and G. These planets reside within the habitable zone, that sweet spot where conditions are just right for liquid water to exist. Imagine a planet with shimmering oceans reflecting the dim light of its red dwarf sun. Could these be the watery worlds we've been searching for? It's a tantalizing possibility. However, the habitable zone is not a guarantee of life. It's simply a region where the potential for life is higher. These planets could be barren deserts or airless wastelands. Only further observations and analysis will reveal the true nature of these intriguing worlds. The presence of water is the holy grail in our search for life beyond Earth. Water is the lifeblood of our planet, and its presence on other worlds would be a strong indicator of potential habitability. But how can we tell if the TRAPPIST-1 planets have water? Astronomers are using a variety of techniques to probe the atmospheres of these distant worlds. One method is called transit spectroscopy. When a planet passes in front of its star, some of the starlight filters through the planet's atmosphere. By analyzing this filtered light, scientists can identify the chemical fingerprints of different molecules, including water vapor. Finding evidence of water on the TRAPPIST-1 planets would be a monumental discovery, bringing us one step closer to answering the age-old question, are we alone in the universe? Section 5. Eyes on the prize. The James Webb Space Telescope's quest to unveil TRAPPIST-1. The James Webb Space Telescope, launched in 2021, is the most powerful space telescope ever built. It's like a giant magnifying glass in space, allowing us to peer deeper into the cosmos than ever before. And TRAPPIST-1 is one of its prime targets. The JWST is equipped with instruments that can analyze the atmospheres of exoplanets, those planets beyond our solar system, with unprecedented detail. It can detect the faintest traces of molecules, including water, methane, and carbon dioxide, which could indicate the presence of life. Think of the JWST as a cosmic detective, gathering clues about the TRAPPIST-1 system and its potential for harboring life. Its observations will be crucial in our quest to understand this intriguing planetary system. Section 6. A Distant Shore. The Challenges of Interstellar Travel to TRAPPIST-1. The discovery of TRAPPIST-1 has ignited our imaginations, making us dream of one day traveling to these distant worlds. But interstellar travel is no walk in the park. It's a challenge of extraordinary proportions, fraught with technological and logistical hurdles. First and foremost, the distances involved are mind-boggling. TRAPPIST-1 is 40 light-years away, which means it would take light, traveling at the fastest speed possible, 40 years to get there. Even with our most advanced spacecraft, a journey to TRAPPIST-1 would take tens of thousands of years. And then there's the issue of fuel. Traditional chemical rockets, like those that launched the Apollo missions, simply don't have enough oomph to propel us across such vast interstellar distances. We would need to develop entirely new propulsion systems, perhaps harnessing the power of fusion or antimatter, to even contemplate such a journey. Section 7. Reaching for the Stars, Imagining Future Space Travel to TRAPPIST-1. Despite the challenges, the human spirit of exploration is undeterred. Our quest to explore the unknown has always driven us to push the boundaries of what is possible. Scientists and engineers are already brainstorming innovative concepts for interstellar travel that could one day make a trip to TRAPPIST-1 a reality. These visionaries are working tirelessly, combining their expertise to overcome the immense technical challenges that lie ahead. One such concept is the solar sail, a spacecraft propelled by the pressure of sunlight. This idea, though seemingly simple, could revolutionize the way we think about space travel. Imagine a giant, reflective sail, thinner than a human hair, unfurling in the vacuum of space, catching the sun's rays, and carrying a spacecraft across the cosmos. This method of propulsion could allow us to travel vast distances without the need for traditional fuel. Another intriguing concept is the fusion rocket, a spacecraft powered by the same nuclear reactions that fuel the stars. Fusion technology holds the promise of providing a nearly limitless source of energy. Fusion reactions release enormous amounts of energy, potentially allowing us to achieve speeds that would make interstellar travel feasible within a human lifetime. This could open up new frontiers for humanity, enabling us to explore distant star systems like TRAPPIST-1. These concepts may seem like science fiction today, but so did the idea of landing on the moon just a few generations ago. The Apollo missions showed us that with determination and innovation, we can achieve the seemingly impossible. With continued ingenuity and determination, who knows what the future holds for interstellar travel? The dream of reaching TRAPPIST-1 may one day become a reality, opening up a new chapter in the story of human exploration. Section 8. A New Home Among the Stars, Life on a TRAPPIST-1 Planet. Let's indulge our imaginations for a moment. Picture yourself standing on the surface of a distant world, far from the familiar sights and sounds of Earth. Imagine we've overcome the challenges of interstellar travel and arrived at one of the potentially habitable planets in the TRAPPIST-1 system. This journey, once thought impossible, has now become a reality. What would it be like to set foot on this alien world? The ground beneath our feet would be foreign, the air filled with unfamiliar scents. The first thing we might notice is the dim reddish light of the TRAPPIST-1 sun. This red dwarf star, much cooler and smaller than our sun, would bathe the planet in a soft, eerie glow. It would cast an eerie glow on the landscape, unlike the warm, familiar sunlight we're used to on Earth. Shadows would be longer, and the colors of the terrain would appear more muted and mysterious. The sky might be a kaleidoscope of colors, with the other planets in the system visible as bright dots, perhaps even eclipsing each other in a mesmerizing celestial dance. Imagine watching multiple sunsets and sunrises in a single day. The gravity on these planets might be slightly different from Earth's, making us feel a little heavier or lighter depending on the planet's mass. This change in gravity would affect everything from our movements to the way we build structures. And the plants and animals, if they exist, would have evolved under these unique conditions, resulting in life forms unlike anything we've ever seen before. These alien ecosystems would be a treasure trove of new discoveries, each species adapted to the specific challenges of its environment. Section 9. The Final Frontier. A universe of possibilities awaits. The TRAPPIST-1 system is a testament to the boundless wonders of the universe. It's a reminder that we are still in the early chapters of exploring our cosmic neighborhood. There are countless stars and planets out there, each with its own story to tell. The discovery of TRAPPIST-1 has rekindled our sense of wonder and fueled our desire to explore the great unknown. It's a reminder that the universe is full of surprises and that the quest to understand our place in the cosmos is just beginning. Perhaps one day, our descendants will venture to these distant worlds, carrying with them the spirit of curiosity and the thirst for knowledge that has driven our species since we first looked up at the stars. The final frontier awaits.